Hey guys, in this video I want to go ahead and talk to you about Pascal's triangle and the binomial theorem. Okay, and named after the French mathematician Blaise Pascal, but he was able to find a pattern for the binomial coefficient. So if you have a binomial and you wanted to expand it that are higher degrees, this triangle is actually kind of gives you a shortcut to do it. And the way we develop the shortcut, we start off with three ones, 1, 1, 1. And so this number is derived from adding these two. So 1 plus 1 is 2. So then you're going to have 1 at the corners. You always have 1 at the corners. And then what you do is you add this one. 1 plus 2 is 3. 2 plus 1 is another 3. And then you still have 1s at the corner, at the very ends. And then 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then at the 1s at the ends, you still have a 1. And then the last one here is 1 plus 4 is 5, 4 plus 6, 10, 6 plus 4, another 10, 4 plus 1, 5, and still at the end. And it just continues infinitum. So like if I wanted to go ahead and do to the power of 6, it would be 5 plus 1 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is another 6. And what I would do is I would add a 1 at the very end, on the endpoints. And this would be a binomial of a plus b to the 6th power. And I could use these are the coefficients that I would use to multiply in order to go ahead and expand this binomial, because I don't want to be doing a plus b 6 times. It would just take too long. And another thing, guys, notice, remember, we start off with 0. We don't start off at 1. Anything to the 0 power is always 1. Okay, now the only other thing you have to remember with this guy is that the leading coefficients, the degrees, okay, the a part, okay, it starts descending from left to right, while the constant coefficient starts ascending. And what do I mean by that? Well, if you notice, if I have a plus b to the 3rd power, okay, you notice here, it started off with a to the 3rd, right here. So that's the first one, a to the 3rd power. And then you use a plus 3. That's the coefficient, that's the constant that you're going to use to multiply the coefficient. And then a, you notice it goes 3, and then it goes to the 2nd power, and then the b comes up. Okay, and then that's 2 here and 1 here. That still makes a polynomial of 3. And then it continues plus 3, and then the a value drops down another one and becomes a 1, and the b increases, so that becomes a 2. So it's still 1 plus 2 is 3. And then finally the last one is just the b. The a is gone because there's no more a's, and b becomes the cubic. And this is what I would use to go ahead and write an expansion. And that becomes helpful because let's say you had one something like this, 2x plus 3y to the 3rd power. Okay, it's efficient to go ahead and use a triangle instead of going and just multiplying everything 2x plus 3y, 3 times. So you just got to make sure you label the appropriate coefficients. So a is your 2x, b is your 3y. So if I know this expansion here, that's my a, okay, and that's my b. And then I just go ahead and a again, and that's b. And notice how I have to, everything inside the parentheses is raised to the 2nd power or to the 3rd power. So when I go ahead and expand this, 2x to the 3rd, remember it's 2 to the 3rd is 8. So that becomes 8x cubed. 2 to the 2nd is 4. 4 times 3 is 12, times 3 is 36. X squared and then y. And then over here, 3 squared is 9. 9 times 6 is 54. X and then y squared. And then the last one, 3 cubed is 27y cubed. So this would be the expansion of this binomial right here. So I'm going to go ahead and do a couple just to kind of give you guys an idea of how to do it. Okay. And remember, if you forget, you can just create the triangle. It's not very difficult to do. But I'm going to go use this one, use the power of 4. So I'm going to do this one here. But first I'm going to label my a and b. So a is my x. I just didn't make it too difficult because sometimes these numbers can get a little bit big. And then your b, I'm going to use the whole thing here, the negatives as well. So negative 2y, okay? So if you look at your expansion here, you're going to have a, okay, to the 4th plus, and then b, then you're going to go to the next number, it's 4, and then a to the 3rd, and then b starts to show up, plus 6, a to the second, and then you increase b by 1, so that's 2 plus 2, that's still a degree of 4. And then you keep going 4, and then a drops down another one, so it just becomes a. The b increases to 3. And then finally, the last one, there's no more a, and you just have b to the 4th power. Okay? And that helps me out because now I know what to put for a and b. Okay, now a is equal to x, so I'm going to do x. I'll just put it in parentheses just to do it the long way. Okay, and then x to the 3rd, and then b is negative 2y. Okay, plus 6, and then you just start filling in everything, the square. Okay, and you just got to be careful because we're just learning right now, and it's very easy to make a mistake, especially with all those exponents. A is x again. B is negative 2y to the 3rd, plus, and then your last one, the b is negative 2y to the 4th. All right, so you notice how I had to use the b, the negative in front of that 2. So now I just go ahead and do my math. So x to the 4th is x 4th, plus, actually, it's going to be a minus because it's a negative, right? So this is 4 times negative 2 is negative 8, and that'll be x cubed y. And this becomes negative 2 squared is 4, positive 4 times 6, well, that's 24. And then we have x squared and y squared. And then negative 2 cubed is negative 8 times 4 is negative 32. So that's not too bad, x. And then y to the 3rd. And then the last one, negative 2 to the 4th, is a positive value of 16. 16 y to the 4th. And that would be your whole expansion. But notice how I did that. First I had to label my a and my b. Then use the expansion, substitute so I don't make a mistake, and then just go carefully one progression at a time. Let's go ahead and do one more, a long one, okay? And let's go ahead and label our a and b. So a is going to be 3x, and b is going to be 4y. All right, so now what's my expansion? Now, my expansion is a to the 5th, and then a to the 4th, and then the b shows up, but it has the coefficient of 5. Then plus, and then we have 10. The a becomes a 3, the b shows up with becomes a 2, and then keeps going up with a 10. A becomes a square, and then b becomes a cubed. And then the last one, 5, the a, and then b to the 4th. And the last one is just b to the 5th. Okay, so you got to make sure you remember to use those leading coefficients here, the 5, 10, 10, 5. Okay, just like we did in this guy right here. You see the 4, the 6, the 4. Okay, so let's go ahead and substitute now. So a is going to be 3x, and that's going to be to the 5th. So you can see how these numbers can sometimes get big. So then 3x, and then to the 4th. And then b is 4y, plus, and then 10. A is 3x cubed, b is 4y, and then that's squared, plus, and then that's another 10. And then a is 3x squared and 4y cubed, plus 5. A is 3x, and then 4y to the 4th. And you can see how it becomes kind of tedious sometimes. And the last one is b, it's 4y to the 5th. So I'm going to have to probably use my calculator for this, just because you can already tell it's very large numbers. Okay, so let's go ahead and see if we can do this real quick here. So 3 to the 5th power, well, that's going to give me 243. So that's going to be 243 x to the 5th. 3, so that's 5 times 4 is 20. 3 to the 4th is 81 times 20. That's going to be 1620, plus 1620 x to the 4th and y, plus, and then see 3 cubed is 27 times 10 is 270 times 16, 270 times 16. That's going to give me 4320. And then that becomes x cubed and y squared. And then keep going. 3 squared is 9. That times 10 is 90. 90 times 4 cubed. 4 cubed is 64. So 64 times 90 is 5,760. And that's x squared y cubed. And just keep going. And then 3 times 5 is 15. And then 4 to the 4th power is 256 times 15. That's going to be 3840. 3840, and then x and y to the 4th. And then the last one is 4 to the 5th power. And 4 to the 5th power is 1024. And that's going to be y to the 5th. So you can see how it kind of gets kind of cumbersome and sometimes tedious. But hopefully you understand, if your professor gives you these, just how to set it up. And all this, make sure you label your A, your B, make sure you understand the binomial expansion here, and then substitute, and then do the math very carefully. Alright guys, hopefully that helps. I'll see you guys next time.